I'm Anil Kumar, and here is a very interesting video in which we'll explore domain, that too of functions composed with its own inverse. That is to say, what is the domain of a function which is f of f inverse of x? What is the domain of the function f of f inverse x? That is the question for you. Now, as you know, f of f inverse x is equals to x. Now, for any function, you can take any function. F of f inverse x will always be x. That's the whole idea, right? When you reverse the operation, you get what you started with. So basically, if you have an operation here, then any input which goes into this and then comes out by performing an operation which is f. Now if you throw that output back, then you should get what had gone in, and that you get if you do inverse of the operation. Do you understand? So the combination is, if x is the input, right, then y is the output, but when you throw in y, you should get x with inverse of a function. So that is kind of the definition, and therefore f of f inverse s is always x. Now the question is, what is the domain of f inverse x? That is the question. Now, f of f inverse x will always give you x. So if you see this x, it is kind of a straight line, right, which divides your coordinate plane diagonally. So basically, you have a line which is this. So that is what we are talking about. So we are saying, what is the domain of f inverse x? Is it without any restriction? That is the question. Think about it. How can you come up with this answer? Think about it. Take some examples. So what we will do is we'll also take up some examples and then figure it out. So let me take an example of a function which has some restrictions. So let us say we take an example with which we have already worked in this video, so that we'll have kind of a link, right? So let us say 1 over x plus 1 is our example. So we are saying f of x is 1 over x plus 1, and we know clearly that x cannot be equal to minus 1 for this particular function. Now, first, let us find inverse of this function. To find inverse, we have to write this as y equals to 1 over x plus 1, and then we will interchange. So we write x equals to 1 over y plus 1, and then we can cross multiply. So let me do it here, since I may run out of space. So what we'll have y plus 1 equals to 1 over x, or y equals to 1 over x minus 1, right? So that gives us inverse of the function, right? So let me write down inverse of this function as f inverse x equals to 1 over x minus 1. So we have inverse of the function now. Okay. Now let's form the composite function, which is f of f inverse x. So okay. So now we'll work on f of f inverse x. Okay. So we are using different things so that it may become easier for you to understand. Okay. So f of f inverse x, and now we know f of f inverse x for us is 1 over x minus 1. So let us write 1 over x minus 1 here. Okay, that's good. Now, what is the function? The function is 1 over x plus 1. So we can write this as equal to, let's write this as equal to 1 over, now instead of this x, I will write all this. Okay, so it is 1 over x minus 1, and we already have plus 1 there. Good. So that gives us 1 over minus 1 plus 1 is 0, 1 over x, and that indeed is equal to x. Perfect. Now we get this result. Now you tell me, what is the restriction on this function? Huge, right? Now, as you can see very clearly, that one of the restrictions which we can see is that in this function we have the term 1 over x. So definitely, we can now write down one restriction that this function has is that x is not equal to 0, right? X is not equal to 0. Now, since we are doing inverse of a function itself, the function has a restriction, and the restriction here is that f of x is equals to 1 over x plus 1, where x cannot be equals to minus 1. So we should have two restrictions for this case, right? Now, how do we justify that? To justify that, what we will do is, we will do kind of reverse operation. That is to say, we will now find what is f inverse of f of x. You get the idea. What is f inverse of f of x? So let's do the other way, right? We'll get the same answer, of course, because always the inverse and functions, when they are combined together, you get x, right? So what is f of x? F of x is 1 over x plus 1. Now this is equal to f inverse. F inverse x is here. So we will substitute, instead of 1 over x, we will write 1 over this number, which is 1 over x plus 1, right? And we have minus 1. This is f inverse x function, where we have substituted inside function for x. Got it? Okay. Now, let's simplify this. Now that gives us x plus 1 over 1 minus 1. And that is indeed equal to x. You get the idea. So again, we found the same result, that this is also equal to x. So one thing is very critical about finding composite functions with their own inverse. You get the same result x, right? Either way you work, right? Now here, what is the restriction? Clearly, once you substitute this here, we have a restriction, that is x is not equal to minus 1. And therefore, we have two restrictions whenever the functions and their inverse are involved for making composite functions, right? So now, as a rule, we can write from here that the domain of such a composition where inverse is involved should consider restrictions of function and its inverse, both. So this is what is a very important conclusion from all we did, and therefore we can write down our answer that domain for this function should be, which is simple, right? F inverse of f inverse x is x. In this particular case, if f of x is 1 over x plus 1, then the restriction will be that x belongs to real numbers where x is not equal to 0, as we found here from the inverse, and is not equals to minus 1, as in the case of the function given to us. And therefore, in this particular line, we have two different restrictions incorporated. One, we cannot have 0 x value, so there is a hole here, and at minus 1, let us say this is minus 1 for us, then there's a hole here. So this now represents our function, our composite function, which has been formed with f of x equals to 1 over x. So this is for f of f inverse x, where, let me write down here in a block so that you understand what we are trying to do, where f of x is equals to 1 over x plus 1, right? So if the question is, what is the domain of f inverse, f of f inverse x, where f of x is equals to 1 over x plus 1, then all this shows that we have to look for restrictions on the function itself and also on its inverse. So find its inverse, which we calculated, which you should calculate, right? So once you find the inverse, you will get inverse of the function as equals to here, right? So it is 1 over x minus 1. So the restrictions will include both the restrictions, and that is the result. So this is y equals to x, okay, where y is this function f of f inverse x with these two restrictions. So that is what I want to highlight with the help of this video. I hope the concept is clear to you all. So whenever we are creating functions from two functions, and if inverses are involved, in that case we have to consider restrictions in both the function and the inverse. But in case inverse is not involved, then we have to find the restrictions from the final composite function and the inside function. So that is how you can connect previous video with this video and find domain of composite functions as a whole. I hope that helps. Thank you. And I'm Anil Kumar. You can subscribe to my videos and learn a lot. All the best.